He will take you through the class. Thank you.
Good morning, everyone. Okay, sorry, we are already in afternoon. This is travel one. I will be taking you through PhD 201, which is biostatistics. By virtue of the situation that is on ground, so we have actually decided to embrace the technological aspect of life in terms of making use of it to facilitate the required lecture series that you need for the forthcoming examination. What I'm trying to say in essence is that for this particular for this particular course, we have a total number of 9 study sessions. And of all the 9 study sessions, we are going to do justice to each and every one of them as the time permits. So I want to seek for your indulgence to kindly pay the rapt attention that is needed so as for you to get the adequate understanding of the subject matter, which is the biostatistics. Now, for this purpose, I've personally come up with some slides that cut across all the various study sessions that we have in the biostatistics study guide. So, and that is what I'm going to be sharing with you now. So I want to implore you once again that you should pay attention as we go through the respective slides. Let me share the slide with you. I don't know if you are seeing it.
Yeah, they can see it.
All right. This is the slides that we are going to be going through. And if you can see, we see that we have a total number of 35 slides. And I'm going to start, touching it from study session 1, just as we have in the slides respectively. These are the outline from definition and use of biostatistics up to number 30, which is the importance of health data in biostatistics. Now, what is biostatistics? Generally, the word statistics is not something that we are not familiar with. Even as far back as the time that we were still in junior classes, even in our primary school days, the word statistics has been, and so it is even as of this moment that we are talking. Now, the only difference there is just the bow that you may a bit be finding difficult. But what I want to say is that you don't have to panic at all. Every one of us knows what bio means. Everyone knows what bio means, and which is a part of biology. Some people are disturbing this class. I don't know.
Let's continue. I will remove them from the class now.
So it's just the word bow that may give you a kind of a panic. But I want to implore you that you just take it calm. The word bow is just a regular word that is derived from the word biology. And don't forget that biology itself, as we were taught in the in our junior classes, biology is a kind of a study of living things, how they relate, how they, you know, go by their own way of living in terms of their respective characteristics, such as ecosystem, such as the respiratory system, such as the reproductive system, and a number of other facts that you might have been taught. Now, the word statistics itself has to do with the accumulation of data, tracking, analyzing, and application of such data. Now, what I want to bring out here is that biostatistics is just simply the application of statistics to the field of biology. I mean, to the field of medicals, which is the one that you have at the moment. Now, definitely in a series of health facilities that we have, there are some point in time that statistics will actually, have to come in place if such an health facility has to work properly. And this will lead us to the uses of biostatistics. Just as we have on the slide here, you can definitely see that biostatistics is commonly used in large scale of effort, and this range from drug testing and environmental modeling. It can as well be used and in vital use of evaluating the spread of various diseases that might erupt. Also, it is heavily relied upon to track and interpret data and to make recommendations based on those interpretations. What we are trying to say here is that when you have some set of data, having analyzed them, then you, through the result of the analysis, you can come up with some results that you can consequently interpret, which will make you make the appropriate recommendation as far as the situation is concerned. Also, biostatistics can help to solve certain environmental and biological problems. It is also used in modeling, in hypothesizing, by way of predicting the future. That is, trying to have a kind of foreknowledge or foresight of what is to come as a result of the present situation. Another use of biostatistics is that it can be used to determine how diseases develop, how they progress, and how they spread. Another one is that biostatistics has itself played an integral role in modern medicine, in everything from analyzing the data to determining if a treatment will occur. We work depending on the clinical trials. Now, if you look at the scenario that we had now, especially this corona pandemic, you see that day in and out, there are a series of researches that are going on, which are aimed at finding a lasting solution to the present pandemic. And before this could be achieved, you will agree with me that they always need statistics. In fact, if I don't know too much, I am aware of your platform. You might have been seeing some research questionnaires in form of Google link being sent to you that you should try to fill and some other like that. Now, what those things are meant for are to kind of come up with reasonable statistics, so as the data could be gathered and consequently analyzed for further processing. And definitely, the result of those will bring about a solution, potential solutions, so to say, to the issue of pandemic or any form of pandemic that is ravaging the world at the moment. From here, I want to move to frequency distribution and types. There is no way.
Disappointment.
There is no way you could talk of biostatistics without talking about some parameters, so to say, or some kind of indices upon which statistics could be based. And part of this, we have all these benchmarks such as the mean, the median, we have the mode, standard deviation, frequency, and a number of other things like that. Now, but what is important is that, and what I want us to get from this particular subtopic is that, when you have data, some data could be that voluminous to the extent that even mere looking at them, you may not be able to come up, you may not be able to have better understanding of the trend by which such data goes. And this will actually bring about you needing a kind of frequency distribution, a kind of arranging the data in a chronological order so that it will be easily interpretable and easily understood by anybody that picks up such document. Now, frequency distribution is just an arrangement of the values so that one or more variables could take a portion or the other in the table. Now, take for instance, you have, okay, let me go ahead. There is an example that I'll give you in the next slide so that you get it better. Now, each entry in the table contains, each entry in the table itself contains the frequency or count of the number of occurrences of values. Now, that values could as well mean a kind of observation within a particular group or interval. And in this way, what normally happens is that the table itself summarizes the distribution of values in the sample. Now, I want to say this at the point that there are two major types of frequency distribution depending on the type of data that we are dealing with. Now we have the categorical frequency distribution and we have the grouped frequency distribution. Now for the first one, which is the categorical frequency distribution, now this is used for data that can be used for specific categories such as normal or ordinal level data. Now when we talk about normal number, we all know our regular number, which is from 0 to 9. Now, other ones could as well go by way of combining, any of those numbers. Perhaps you want to get number 23, that means you are going to combine 2 and 3. Then you have 23, 45, and so on and so forth. But the basic ones that we have ranges from figure 0, 1, 2, 3, 4, 5, and 6. Also, the ordinal level number excuse me, just as I was saying, the ordinal level data, they can be in form of number that are being used for the purpose of nomenclature. Now, take for instance, we have some set of players, football players on the field. You know that each of them has a particular number inscribed at the back of his or her jersey. So that one is just for the purpose of labeling that so person who is playing so wing. This is what we use in recognizing him or identifying him. Now, for the group frequency distribution, this is used with quantitative data, and the group may include more than one unit of measurement. Now, by way of this, I want to specifically talk about the reasons why construction of frequency distribution is necessary. And that is what we'll be seeing below here. That there are several reasons for constructing a frequency distribution. And the first one is that for you to be able to organize the data in a meaningful, intelligible way, just like I told you initially, that if the data are just in their raw form, now for you to be able to have better understanding of the trend with which the data goes, that becomes a bit difficult. Now, that is the essence of constructing a frequency distribution table. Another one is that to enable the reader to determine the nature or the shape of the distribution. Another one is that to facilitate computational procedures for measures of average and spread. Also, it can also be used to draw charts and graphs for the presentation of data. And last but not the least is that it can be used to enable the reader to make comparison among different data sets. Okay, now if you are to construct a frequency distribution table, how do you go about it? Now, on this slide, I've given you the concise steps to how you can construct a reasonable and an understandable frequency distribution table. And the first step when you are to do that is that you have to divide the results into intervals and then count the number of results in each interval. Now, what this means is that, say for instance, you have a range of numbers. Now, you can have a kind of, maybe the numbers cut across from figure 10 to 335. Now, you may decide to have your interval to be like 10-10. Now, you can have like from 10 to 20. So what are the numbers that fall between 10 and 20? So any number such as 11, 12, 13, 14, 15, 16, 17, 18, and 20. That number that falls within the range, then you will record that as to be for that interval. Now, you can go ahead and have 20 to 30, 30 to 40, 40 to 50, like that. Although mathematically it can actually be like this. You may have like the one that starts from 10. You may have something like from 9.5 to 29.5. Then you have from 30.5 to 40 to 39.5, and so on and so forth. Now, you now count the number of observations, the number of numbers that fall within each range or interval. Then that's what you record for the frequency. The step 2 now is that you now make a table with separate columns for the interval of numbers, and you label them as X. That is, you have X column, that is the column that will be for X, the column that will be for tally, and the column that will be for the frequency. And last but not the least is that you now read the list of data from left to right, just like I explained earlier, and place a tally mark in the appropriate row. Then by doing this, you add up the number of tally marks in each row and record them in the final column, which is the required frequency that you need. Now let's look at this simple example so that you have better understanding of what I just explained. Now look at this question. I said a survey was taken on Maple Avenue. Now, in each of 20 homes, people were asked how many cars were registered to their households, and the results obtained were recorded as follows. You can see them. One, you can see those are the results recorded. Those are the ones that I highlighted. So I have 1, 2, 1, 0, 3, 4, 0, 1, 1, 1, 2, 2, 3, 2, 3, 2, 1, 4, 0, 0. Now, the column that I was talking about, is what we have here. You can see that we have number of cars, because we are talking about cars in the question. Then we have the tally, which is just a kind of strokes that you take. But for each stroke, once it gets to 4, the last one to make it 5 will be what? Will be a cross or a slash over the other 4. Now, for 0 now, you know that you can see that the range or the number of cars recorded range from 0 to 4. That's why we have 0, 1, 2, 3, 4 in the first column here, which is the number of cars. And for 0, we have 4. You can count it together to confirm that. This is first 0, 1. Another one is, this is 2. This is 2. This is the first one. We have 1 here, 2. Then we have the last 2 here. This is 3 and 4. So that's how we have this 4. Now, how many of them registered 1 car each? So those are 1, 2, 3, 4, 5, then 6, which is the last one. Now, look at this, the way that this one is written. Let me zoom in so that you see it clearly. Now, you see that this one is 6. Now, I've told you initially that when you have 4, you just continue counting it like that till you get to 4. Now, but when it is 5, after the last 4, then you now make a kind of slash on it. That's how we have. So this bunch now is 5. So 5, then you make another one, which is what? 1. So 5 plus 1, that's how we have 6 here. Now, take for instance, it is 12. Then that means we have this bunch 2 times, that is 5, 5. You first of all make this one 5, then you make another one 5, then 1, 2 to make it 12. I just use that one as an illustration. Then for 2, it is 5. Then for 3, it is just 3. And the last one, which is 4, it is just 2. So with this, you have been able to break or represent the data in a meaningful form. So anybody that sees this, it becomes, a little bit easier for such a person to be able to, okay, it's just 0 people. It's just 4 people that didn't register any car. 6 people registered 1, 5 registered 2, and so on and so forth. Now, this data can as well be represented on an histogram. We call it frequency histogram. It can as well be represented in a bar chart. It can be represented in a pie chart. It can be represented in a frequency distribution, which is the one that we have done now. Now, let me take you through those other ones too, so that you get it better. Now, this is a frequency histogram. It's just a graphical way to summarize a frequency distribution. Now, look at this diagram. This is y-axis. I hope you are seeing my cursor. Now, this is y-axis, which we have the frequency, which is also the number of children. This is a different question entirely, not the same question as the one that we did. So it's just a different question entirely. Now, I'm just showing you the representation. Now, distribution of children's height. Now, look at the why are the x-axis, that is the height measured in centimeters. Now, for the first one, you have 120 to less than 130. So this is the range I was talking about the other time, that you can have from 10 to 20, from 20 to 30, and so on and so forth. Now, you can see the range here now. You see that this one too is a kind of 10 centimeter difference, because we have 120 to 130, 130 to 140, 140 to 150, 150 to 160, and so on and so forth. Now, you can see now that there is something that is peculiar to this. Now, for those children that falls within 120 to less than 130 height of a centimeter height, now you see that they are like 9, because if you look at this frequency, that is the y-axis, if you look at this place, you trace it down, though we may not be able to get the exact point there because we are not using graph, but it is obvious that this thing falls between 8 and 9, and which can assumed to be 9, although it may not necessarily be 9, but we are just having a kind of assumption. So it might not be 9 really, but at least let's assume it is 9. So we can see that this is 9 here. For this one, it is 10. That is from 130 to 140, we have 10. From 140 to 150, we have, that would be what? That would be 13. And so on and so forth. But one thing that I want you to take cognizance of here before we move to bar chart is that now you see that the edge of the first group meshes with the edge of the second group. And also the edge of the second group meshes with the edge of the other group, and so on and so forth. Now, which is not like this for bar chart. I will show you now. Now, this is bar chart now. This is bar chart. Now, a bar chart is a type of graph in which each column represents a categorical variable or a discrete or group numerical value. Now, look at what we are saying now. Now, this is birthplace of some children. The number of children is what we have on the y-axis here, and the birthplace in terms of country are what we have on the x-axis, which is Australia, Italy, New Zealand, India, USA, and the other one. Now, the country of birth is marked to the number of children that are born or that were born, so to say, in that particular country. Like the first one, now this is Australia. We have 16 children that were given birth to in that place. For Italy, we have 10. For New Zealand, we have, that is 9. That is 9. For India, we have 8. For USA, we have 4. Now, but if you look at it, comparing this, that is comparing the bar chart with histogram, they look a bit similar, but there is a major difference between them, which is that this one is spaced. That is, you can see that the Australia is standing on its own, Italy stands on its own, and others each stand on their own. Now, that is the main difference between them. Now, let me take you to pie chart now. Now, pie chart also is another means by which you can represent your data. And pie charts are visually way of displaying how the total data are distributed between different categories. Similar uses of pie charts would be to show the percentage of the total vote received by each party in a particular election. Now, what we are saying here is that you see that what we have here, we have represented them in terms of percentage. Now, but don't forget that the total number of angles in a circle is 360 degrees. And that is why we have this circle like this now. For each percentage, they have their degree of which they cover. Grace, you are disturbing this class. Grace, if you are disturbing this class.
You have to think about the thing is, like, let me share. The master, so why would I be stressing my brain and be thinking about things?
Okay, now, sorry about that. I was trying to mute those people that are disturbing the lecture. Now, just like I was saying, so each of these parameters measured in terms of wildlife parks and zones, historic houses and monuments, museums and galleries, theme parks, and others. Each of them, in terms of percentage, has their own degree representation. That is the portion with which they cover within the entire circle of 360 degrees. Now, let's talk about application of biostatistics in medicine. Now, biostatistics has found, just like I said earlier, that statistics has found a wide range of application in different kind of fields. But specifically for the purpose of this class, I will limit them to those of biostatistics, that is, as they are peculiar to medical field. Now, public health, including epidemiology, health services research, nutrition, environmental health, and healthcare policies, as well as management, makes use of biostatistics for evaluation of their activities. What this means is that it is statistics that will inform them of the necessary action to be taken. Take, for instance, in an health institution or in an health facility now, if you discover that there is a particular ailment that people continue bringing to that health facility. Now, it means, now if you are able to analyze the data, now take for instance, now you just decide to do a kind of periodic analysis of the data that you have in your health facility. Now, you now discover that there is a particular ailment that is prominent, that is a particular ailment that people do bring to health facility. Now, you are able to do the analysis. Now, the interpretation of that is that you will be needing more of the materials to resuscitate such patients than any other. And by that, it means that you have to equip your store, all your equipment, and other facilities that you make use of, so as to be able to meet up with the requirement of those people that keep coming with that same ailment. And that's what that point number one is just trying to tell you. And also, what again, we can, like nutrition. Now, so there are some maybe there are some let me say some beverage companies. Now, once they see that, once research or a kind of data analysis of an institution proves that there are some particular nutrients that is being needed in the body of a patient. Take for instance, like children now, they discover that each time children or the parents of any child brings him or her to the health facility, it is the same ailment, or it's the same prescription that the doctor do give then they can see it as okay, it will be a kind of avenue for them to double their own next effort by way of producing more of their own products in terms of nutritional content. Can be in terms of drug, it can be in terms of milk, can be in terms of the food that the children consume, and a number of other things like that. Now, another point is that biostatistics helps in designing and analyzing of clinical trials in medicine. So what they are trying to say here is that it bring about a means by which you can experiment your medical findings, so to say. Another thing is that population is used in population genetics and statistical genetics in order to link variation in genotype with a variation in phenotype. Other one is that researchers employ scientific methods to gather data on human population samples, such as the age, the sex, they can also be in form of their demographic information in terms of where they came from, and any other human population characteristics, can be in terms of their maternal origin, can be in terms of what they consume, and a number of other things like that. So this will inform them of the necessary action to be taken in order to resuscitate anybody that comes up with one ailment or the other. Now, another thing is this, let me say this before we forge ahead. Now, you discover that each time a patient comes to the health facility, you see that the I don't know whether it's the nurses or the auxiliary nurses, they get the details of the patient in terms of the temperature reading, in terms of pressure reading. Some even go to the extent of checking for a number of parameters as peculiar to such a patient, especially when such patient has an historic information which they might have seen on their health record. Now let's move to probability. Probability. Okay, I don't know whether you have any question. If you have any, you can raise up your hand. Let me see, so that I will entertain you before we go ahead. Anybody with any question? If you have, raise up your hand so that I will unmute you before we continue. Anybody? Okay, that means we can go ahead.
Hello.
All right. What's his name? Joby or something. I'm hearing you. What's your question?
Please, I need the slideshow for the I enter late.
Are you not seeing the slideshow?
No, the first few ones. I enter when you were talking about the statistics.
It's okay, that is noted. Now, who again?
Thank you.
Good afternoon, sir.
Good afternoon.
Yes, sir. Please, can you please explain that pie chart again? I'm kind of mixing it up with bar chart, although the diagrammatic representation is quite different, but the data, I'm trying to differentiate it, what kind of data that can be found in each of them. Thank you, sir.
All right. Who again? Is there any other person else?
Yes, sir.
All right.
Yes, sir. So I have question on. Can you hear me, sir?
I'm with you. I'm with you. Go ahead.
My question is on the frequency distribution, the
Okay.
categories, the
Okay.
categorical uh, frequency and the group. So I
Okay.
don't understand.
All right.
Thank you.
The last person.
Hello, sir.
All right.
Can you hear me, sir?
Good morning.
Can you hear me, sir?
I'm with you. Go ahead. Everybody's hearing you.
All right, sir. Please, sir, I missed the part because my network got disconnected. I will miss the parts from when you were explaining the definition of biostatistics, where you said about bio and statistics. Then I missed the part before you went, okay, I got the part uses. I missed the part before you got to the histogram and bar charts. I quite understand the difference between histogram, bar charts, and then pie charts. But I don't know what happened in between before you got to that point, sir.
It's okay.
So I want you to verify that. Thank you, sir.
Who is this? Only matter or something. Go ahead. Your question.
Hello, sir.
All right.
Hello, sir.
Okay.
I just asked my question just now. Did you get that, sir?
Okay. Are you the same? Are you the one that just finished talking now?
Yes, sir. I'm the one, sir.
It's okay. That's good thing. Damilola Akin. Damilola Akin, you are raising your hand. Okay. Let's. Now somebody asked a question about pie chart and bar chart. Okay, let me start from
See the back, see the back, see the back. Oh yeah, just this so that I see the back. This one. Okay. You said?
okay. Now somebody asked, who is that?
Okay, it's spinning.
When I told you Chika is here making money, I thought I was joking.
Already.
It is not Chika house of the but we Chika live my house.
Now somebody asked a question about when we were talking about frequency distribution. Now she asked about categorical frequency distribution and grouped frequency distribution. Now if you go to your study session 1, in the study guide that is in your hand, you see a place where they call, a section there where they talk about scale of measurement. There they are talking about the nominal numbers, the ordinal number, and a number of others. Now, what they are trying to say is that now, if you have a categorical data, there are numbers that are specific. They are specific even in the way by which they have been presented in the form of data that you have now. But if data are group, that is group frequency distribution, you can have something like maybe you are trying to get the, I don't know, which kind of example can I use for you? Okay, let's say you have like that of players, like I said earlier. Or okay, let's say you want to talk about the speed of vehicles, so to say. Now, if you have 2 vehicles now they are moving from a particular location to another location. Take for instance, they are moving from LODLC and they are going to Lagos, and they both take off at the same time. Now, the two of them instantaneously, of course, you don't expect the two of them to get to Lagos at the same time, especially when you are not using the same type of vehicles. Even if they are the same type of vehicles, yet the two will not get there. Now, instantaneously, maybe over a particular distance, you can be getting their speed. That okay, when they take off from ODL, now after they might have covered 1 kilometer, at what speed did they move? Vehicle A, what was the speed that it moved? Vehicle B, what was its own speed of movement? Now, you now get it like that. Now, after 2 kilometers, what is their speed? After 3 kilometers, what is their speed? After 4, and so on until they get to their destination. Now, those type of data cannot be categorical. Are you with me? Now, the way you present that type of data will not be what we refer to as good, and that is the situation whereby you now be making use of range. Now, look at this. Look at this example I gave you.
Sir, please,
now,
you have muted yourself. We can't hear you anymore.
I didn't mute myself. I'm available. Are you hearing me?
Hearing you, sir.
Now look at this question. Look at this example I gave you now. Now, look at these numbers of vehicles. You see that they are specific as against the tally. Now, but in the case of the group, this thing that we talked about, the other one, the group frequency distribution, what you'll be having is that you can have the kind of rate like from 1 to 1.5. Are you with me? 1.5 to 2, 2.5 to 3, 3.5 to 4. So it's like a range. You are going to pick the number that falls within the range that you have chosen. Then you now count the number of tallies. Then you now you record your frequency. I don't know whether I'm able to, but just go back to that study session 1, that particular area where they talk about the scale of measurement. Then you get better understanding of what I explained. Now, the other person asked about the difference between bar charts and pie charts. Now, pie charts, of course, the diagram explains it better. Now, when you are talking about pie chart, a pie chart talks about representation of proportions or percentage formation of particular set of data in a group or in a raw data. Now, take for instance now, like this question now, this diagram you are seeing on the board, is like they are trying to talk about, all these what they call it, these maybe like parks or something like recreation centers. Yes, I remember, like recreation centers. You see that they are talking about wildlife parks and zoos. They talk about the historic houses and monuments. They talk about the theme parks. They talk about the museums and galleries. Now take for instance now, they now take a particular amusement park now, where all these things that they have mentioned are. Now, they may decide to look at it as, okay, let's look at the entire land mass of which that amusement park covers. Now, which percentage of the land covers wildlife parks and zoos? What proportion of the land, or what is the percentage of the land covers museums and galleries? Now, of course, they would have given you those ones in terms of figures. Take for instance, maybe the whole land is like a 5 plots of land. They now tell you that museum and galleries covers 1.5 plots of the total 5. Are you with me? The other one, like the theme park, it covers like maybe like one piece, one plot of the whole plot of land, like that, like that, like that. Now you now convert that into degrees. Don't forget that the total degree of the total angle of a circle is 360 degrees. Now by the time you do everything, you arrive at 360, and each of them would have, you know, accosted each, would have accosted the percentage representation of its own on the whole total landmass. Now this is what you are saying. Let me explain it to you once more. Now look at these museums and galleries. Now these museums and galleries, I don't know if I'm getting it clearly, the team is the one that has a larger percentage. Of course it will be. That's 42. And consequently, it is the one that has the highest degree also. Now, this is how to do it. This is how to get the degree representation. Now, take for instance, this one covers like two. Like museums and galleries cover two plots of land of the whole 5 plots. That means you have 2/5. Are you getting it? Times 360. Whatever you have will be what you have here. Will be the degree that you measure with your protractor in this circle. Now, maybe like this 35 now, this one covers like 1.2%. 1.2 plot of land. That you now have 1.2 all over 5. Don't forget the whole land is 5 plots. 1.2/5 times 360 degrees. Whatever you have is what you measure here. Like this one that has 15%. Like this one that is historic houses and monuments. Maybe this one cover like 0.5 plot of land. Then you have 0.5 over total land, which is 5 times 360, and so on. And so that's how they arrive at the degrees that you have there. Then when you are doing this, I want to say that the radius of your circle does not matter. What they are interested in, the radius, you can choose any radius of your own circle depending on the space that you have. Now, but the point of interest are the degree, that is the angle that each of them take in it. I think that is clear now. I think that is clear.
Yes, sir.
Is it clear to you now? I hope that is clear.
Yes, very clear, sir. Thank you.
All right. Now, let's go to probability. Okay, let me reduce this. Okay, yes. Okay, this is, yes. Now, this is probability. In our day-to-day life, even our sleeping and waking up alive, hale and healthy, is by probability. And anyway, I'm talking from the perspective of a scientist. Some people who believe that it is just by nature. We have those ones too. Although it's God that is making everything possible. But scientifically, there is nothing we do that does not involve probability. And probability is simply the chance or likelihood that an event will occur. Are you with me? So now, an event will occur, an event may occur, and it may not occur. So the representation of that, which can also be referred to as the measure of the likelihood that an event will occur, is what is referred to as probability. And to this extent, there are two theories that have been proven, and these are the common group formulation and the cause formulation. For the common groups formulation, it says that the sets are interpreted as events and probability itself as a measure of a class of sets.
Open it.
And for the cause theorem, that one, please let me meet these people that are opening it. Let me meet them. Now, that one says that probability is taken as a primitive, and the emphasis is on constructing a consistent assignment of probability values to propositions. Now, in both cases, the laws of probability are the same, except for technical details. So it depends on your own area of technicality that will determine the formulation or the theory that you go with in the two. But it is proven that the two will definitely lead to the same results. Now, if you look at this mathematical treatment of events, you can see we have joint probability, we have interdependent events, we have mutually exclusive events, we have not mutually exclusive events, we have conditional probability. Now, for each of them, they have their mathematical relationship. Now, if you have probability of A and B, now the representation is that you are having A intersection B. The ones that are interdependent, it means you have probability of A and B, which is as well like the first one, that A intersection B, and it can be splitted, whereby you have probability of A times probability of B. But if they are mutually exclusive events, now what we mean by mutually exclusive events is that when you have two events, that is, when you have two events, the two cannot come out to be positive, or the two cannot come out to be, negative. Now, mutually exclusive events means that the two events, the outcome of two events cannot be the same thing. Now, take for instance, you have let's say you throw two. Okay, let's say you throw a die. Now, you know that when you throw a die, it is either you have the head or the tail. No, not a die, sorry, a coin. When you throw a coin, all these coins that we make use of, I don't know, it's been long I saw something like that now. Since Nigeria is no more spending that again. Now, that coin, when you roll it, you throw it up. It's either you have the head or the front or the back are the same. That's what we are trying to explain here, that the two events cannot happen at the same time. Now, but if it is not mutually exclusive, it means the two can happen at the same time. Then all you have is that A or B. Then P, that is probability of A plus probability of B minus probability of A and B. Now, I just use that to explain. That's not where we are going anyway. Let's move ahead. You have better understanding of it now. Now, let us look at this probability and set theory. Now, look at this diagram that we have. You see that we have a diagram that carries this, is it yellow color or what is this? You have another one that carries sky blue, and you have the green square, the green rectangle that carries the green color, which is C. Now, let us read this memo here. A sample space is defined as a universal set of all possible outcomes from a given experiment. Now, given two events A and B, as we have seen in this diagram now, and given that these events are part of a sample space S, that is, given that this event A and B is happening within the whole of this sample space, which is S, then this sample is represented as a set in the Venn diagram. This is a Venn diagram that we have here in the diagram below. Now, the entire sample space is what you have. You have A, B, and C. Now, but you have to remember that when you have C, if you want to get C now, that is, you want to subtract A and B from the whole of what they have, then you have C to be equal to A union B complement. Now, A and B are the two events happening within C. Now, if you match A and B together, that's the meaning of A union B minus the all of this. That is the implication. That's when you have your C here. Now, but don't forget that your A union B is equal to A plus B. I hope you are seeing this. Don't forget that your A union B, as you have in this bracket, is A plus B minus A intersection B. Now, that is, you match, you are going to have A plus B, that is A, this circle, plus assuming there is no intersection here now, you can just add the two together, A plus B. Now, you now subtract this place now. You subtract this red box, that is where the two connected. You subtract them, that is A intersection. This place is A intersection B. That's what you have in this bracket. So now, A union B now will now be this, that is A minus, A intersection B minus A intersection B. That is A union B. First of all, the essence of removing this middle one is that this one is still inside C. So it's not limited to A and B alone. So what we have there is A intersection B, then standing in the environment of the sample space C. That's how we have this one. Now, I will give you some laws. Then we solve one or two examples to have better understanding of what I'm saying. Now, we have some laws of probability, just as we have here. We have the law of large numbers, the laws of subtraction, law of multiplication, and law of addition of probabilities. Now, the law of large numbers says that the higher the number of trials, the more the accuracy or the frequency of an event outcome. Now, this is what we are trying to say. Now, when you are trying to have a kind of analysis, the higher the data, the higher the number of your trial, the number of observations, this will inform the accuracy of your results whenever it comes out. And that's what you have there. The more accurately the frequency of an event outcome will mirror its actual probability. Then the law of subtraction states that if you know the probability of an event, then you can accurately state the probability of that event not occurring. That is, the probability of, if you know the probability of, let's say, the probability of when you throw a coin will be 1/2. You know that we have head or tail, so that is 2. That is, head is 1, then the other one 1, then 1 plus 1 is 2. Now the probability of having head is that you have 1/2, which is half. Then the probability that head will not occur will now be 1 minus 1/2. That's what they are trying to explain from this law of subtraction, that if you know the probability of an event, then you can accurately state the probability of the event that the probability that the event will not occur. Now, law of multiplication. This one states that the probability of drawing a blue marble from the bag of 5 marbles is 1/5. Now, the probability of drawing a green marble from the remaining set will be 2/4, because, okay, let me read it or it can be 1/2. That is 2 goes in 2 is 1, 2 goes in 4 is 2. Then correctly applying the law of multiplication involves multiplying the two probabilities. Now, 1/5 and 1/2 for a probability of 1/9. Now, this expresses the likelihood of the two events occurring together. Now, what we are trying to say here is this. Now, if you have some set of marble, take for example, you have a box, so they now put some marbles in it of different colors, totaling 5. Now, you now have to take one blue marble from the box. You know that if everything there is 5, now they now have to draw another green marble. Now it means after you have removed one, it would have reduced to 4. So that is the essence of when you now remove the second one, the total number here will now be 4, not 5 again, because you have already removed one before. Then you now so if you have to remove another one again, you have what? 3/3. So now for this case now, it has been reduced to its lowest term, which is 2/4. Then 2 in 2 is 1, 2 in 4 is 2. That's how we have this 1/2. Then from there, if you apply the law of multiplication, you can multiply the two probabilities. Then if you multiply them for a probability of 1/9, then you have the probability of, you have the multiplication of two probabilities, that is 1/5 plus times 1/2. That's the probability of the first one and probability of the second one. Then the law of addition says that the probability of 1 out of 2 events occurring is equal to the sum of the probabilities of each event occurring individually minus probability that both events will occur. Now, population and sampling. Now, we know that there is no way you can perform any data analysis without you having specific population. Population means the general study area or the general facility that you want to study. Now, when you have a population, take for instance the whole of students in your level now, or let me say the whole of students that are offering PhD 201 in nursing department. Now, I now want to do some experiments, or probably I want to conduct a kind of experiment of your locations. Like maybe I want to know where each and every one of you came from. Now, I can say that the entire student in 200 level is my population of study. Now, you can see that it can be defined as including all people or items with the characteristics one wish to understand. That is, you are the one that I want to study. I want to get some facts in a particular area of your class. Now, sampling now means that I'm trying to determine some number of a quarter, let me say a particular size that I will use from among the people in your class, from among the students in your class. Now, what I'm saying is this, sometimes the population could be so large to the extent that if I want to say I want to start considering each and every one of you one after the other, it may be time consuming. And in fact, I might not even be able to finish the research or the analysis on time. And then the issue of sampling comes in. So now, sampling has to do with using statistical analysis in which a predetermined number of observations will be taken from a large population. Now, when you want to do probability sampling, then let me say this, that we have probability sampling and we have the non-probability sampling. Now, for the probability sampling, they include the simple random sampling, we have the systematic sampling, we have the stratified sampling, we have the cluster sampling. But for the non-probability sampling, we have the quarter sampling, we have the purposive sampling, and all that. When we get there, I will explain it to you. Now, let me explain this type of probability sampling one after the other. Our time has gone, but let me explain them briefly. Now, simple random sampling just means I just decide to just come to your class. Probably everyone is in Ogbomoso for maybe for revision or something, or you are here for a jam. So I now come to your class. Now I just let me just pick like some people that I feel they can assist in the analysis or in the research that I want to conduct. Now I may just feel like they can be my samples, Jared, then I will go and use them like that. Now, but what I'm trying to say is that those people that I have chosen, then I need to say that too. Sampling will help you to have the generalized opinion of the population. Now, if I sample your class now, I can use the responses obtained from those people that I have selected to generalize the opinion of everyone in your class. Now, but if I just say simple random sampling, I just say, let me just, now, there could be a kind of sentiment or a bias coming in by way of just maybe I am close to one or two of you. Let me just pick these people that I know. Meanwhile, in the real sense, they may not really be able to provide the necessary information for me to generalize it on your class. That since people have said this, then it means that it is 200 level or the people that are offering PhD 201 that have said it. Now, systematic sampling. Systematic sampling has to do with arranging your population in a systematic manner, such that based on that, I can now decide to pick. Now, this is what I'm saying. I may decide to, I'm still using your class as an instance, I may decide to categorize you into states. Like, okay, let me sample based on the states that each and every one of you came from. Now, I can now say, let me pick from Lagos State, people that are offering PhD 201 that are from Lagos State. I will sample, let me pick like 2 or 3. People from Oyo State, people from Kaduna State, people from Enugu State, and so on and so forth. That is what we mean by systematic sampling. And perhaps if I'm even seeing you, I may decide, okay, let me use system such as the people, all the people that are fair in complexion, fall on one side. The people that are not fair, or probably people that are a bit dark in complexion, then I can also say, from the people that are fair in complexion, I pick my samples. From those that are not fair, I pick my samples. So that's what is meant by systematic sampling. So I can then go ahead and make use of those samples to now generalize and form my own opinion. Systematic sampling can be in any other criteria that you may so desire. I may decide to look at let me use probably the those that are married, that if you are married, fall on one group. Those that are yet to marry, those that are semi-married, and so on and so forth. So I think you get my explanation. Then stratified sampling has to do with when I use, it is similar to systematic, but it is when I make use of general, or let me say natural phenomenon to categorize you. What I mean is I may decide to use age to categorize you, that, you know, there are some things that if not to lie about your age is something that is, that one is just there. You can't manipulate it. Even if you change it on paper, it is still there. Then I may decide to make it like something like, I may use like sex, that let those that are female, let them be on one side. Let those that are male, let them be on one side. And so on and so forth. So the difference between systematic and stratified sampling is that for systematic sampling, uh, anything perceived to be okay can be used for the categorization. But stratified, it has to be natural phenomenon, something that occurs naturally. So that is the only thing I can use for stratifying my population, like the age, like sex, like the race, and some other things like that that you be thought of, that you could think of. Then the last but not the least is the cluster sampling. The cluster sampling has to do with you creating a kind of block for selecting your samples. Now, what is meant by this is this. Now, when you have, let me say, you are all seated in the hall, I will just decide that, okay, for first row, I can divide the first row into two, the second row into two, the fourth row, and so on and so forth. Then I can now decide to now sample, like the first row that I've divided. Now I can pick the first half, that okay, I will sample these people, the second row too, the third row too, and so on. So now, if I'm doing that, I will not now limit it to, I will not limit it to now examine just one of the samples that I have taken. I will make sure that I consider all those people. I don't know whether you understand what I'm saying. Take for instance, you are sitting in columns now. Okay, yes. In your class now, you have four columns. You have rows and columns. The long one can be referred to as the column, and the short one can be referred to as the row. So for the first row now, for the first column, I may say, let me divide it into three. So that is for everybody sitting on the first column, I divided it into three. So I will now pick just a portion. That is the first division. The first one that I divided. That is of the three divisions that I've made. I will pick a group. Then I will move to the second column too. I will divide them into three and pick a group, and so on and so forth. So now what I'm not saying is that the ones I've chosen, they have to ensure that I examine them one after the other. So that is the shortcoming, or let me say, it could be a kind of a busy schedule for anyone using that, especially when statistical analysis, when statistical tools are not involved. Now, this is non-probability sampling, and it's in any sampling method where some elements of population have no chance of selection, or where the probability of selection can be accurately determined. So it involves the selection of elements based on assumptions regarding the population of interest. So the example of these are the accidental, you have the quarter, purposeful, like that of accidental now. Maybe I just decide to enter your class from the back door. I can just say that first person, you are my sample. It can be quarter, it can be purposeful, it can be any other thing that you so desire. Now, I've put down this. Now, just like I said, when you are doing cluster sampling, and you want to use that, you want to use the result of your clustering in your for your analysis, then if you are not making use of statistical tools, the standing one that is known, then it might be a little bit voluminous. Not that you can't do it manually, you can do it, but it depends on the sample size that you are considering. And there are some available statistical packages that we have. Part of it is the SPSS, which is the statistical package for social scientists. We have the Excel. Most of you don't know that the Excel tool can also be used for statistical analysis. So it depends on your level of knowledge about Excel that will determine your level of exposition as regards the use of the statistical analysis, the statistical package that you have on Excel. So majority of us have it, but we don't know its uses. Another one is RStudio, another one is MATLAB, and a number of other tools that we have. Now, but for any form of analysis that you are doing, we have series of benchmarks for inference making. That is, you have the result, you have some values or the result with which you must come out with before you can say that you've really had a good and a reliable analysis. And part of this is the standard deviation. We have the p-value, we have the coefficient of variation, that is the R value, we have the coefficient of determination, which is the R square value, we have the mean, we have the median, we have the mode, we have the skewness, we have the kurtosis. There are a number of them like that. I just try to put some of them here. So there are a number of them that you can definitely make use of to determine and to come up with inference. That is, to come up with I don't know, inference is a kind of recommendations for your research. Now, sampling methods. There are a variety of sampling methods that can be employed individually or in combination, just like I've categorized them earlier to be what? Probability sampling, non-probability sampling. So for the probability sampling, we talk about the what are those things we talk about? We talk about we talk about the skip my memory. Yes, we talk about the systematic sampling, we talk about the cluster sampling, we talk about the stratified sampling, we talk about the simple random sampling. And for the non-probability, we talk about the quarter sampling, we talk about the purposive sampling, we talk about the accidental sampling. But I want to say that all those sampling techniques or methods that we mentioned, they are not limited to those ones. I just decided to pick the peculiar ones for the purpose of this class. Now, but as lovely as these sampling techniques are, there are some factors that influence the choice of each and every one of them. So what is okay for you now, that is the sampling method that you feel is okay, might not be actually be okay for the other person. So it depends on what and where you want to use it for. Now, part of it is that the nature, that the part of the factor is that it depends on nature and the quality of the framework that you are working towards. Another one is the availability of auxiliary information about the unit of frame. Another one is that accuracy of requirements and the need to measure the accuracy. Another one is that whether detailed analysis of the sample is expected or not. Another important thing is the cost or the operational demand of your sampling technique. So you have to put this also into practice, because the reason why I'm saying this is that sooner or later, you are going to get to your final year where you are going to be writing one project or the other as required for you to be a graduate of this higher institution. Then it might require you to do some sampling, go to the field and get some data and some other things. So this lecture will actually give you the required insights into the specific sampling technique or method that you need to choose for your own research. Now, let's move to planning and health program planning. Now, planning is a decision-making process, systematic, and it is continuous on how, when, and where to employ resources in order to achieve future goals. Now, there is nobody that will want to, of course, a number of health facilities, even the federal government, federal and state government establishments, most are done or most are established for the purpose of profit making. And if you are to realize a huge profit, then there is need for you to be able to plan very well so that you will have your goals achieved. And it is not just scheduling, forecasting, or statement of desired results alone, but for you to adequately put in place what are required for you to achieve your goals. Now, health program planning is an organized approach to the provision of quality health services to the people. Now, according to the World Health Organization, they gave the following 5 basic steps in order for us to have health program planned. And the first one is that collection of information that are essential for planning. You have to establish your objective. Also, you have to assess the barriers to health programs and how they can be overcome. Another one is appraising the apparent and potential resources, organizations, personnel, materials, and the funds. And the last one is developing the detailed plan of operations, including the definite mechanisms of the continuous evaluation of the health program. Now, let's move to health statistics. Now, health statistics can indeed help you to know the trend of deadly diseases in our society, and so that we can have appropriate health policies to be formulated and decisions and actions can be taken promptly in order to contain the spread of such diseases. And there are some importances of biostatistics in healthcare system. This includes the utilization of healthcare system. It brings about adequate allocation of resources. It brings about the assessment of needs of the healthcare system, and also it can be used to evaluate quality improvements in every area of the healthcare field. And last but not the least is that it could bring about product development. Now, health manpower planning. Health manpower planning means people who are trained to promote health, to prevent and cure disease, and to rehabilitate the sick. And the major aim of manpower planning is to make it available at the right kind of what I'm trying to say there is that to make available the right personnel, so in the right number and in the right proportion, so with the appropriate skills, so at the right time to do the job as and when due. And there are some of the reasons for health manpower planning. It is done to improve numerical strength and health manpower in order to cope with the ever-increasing population and healthcare demands. And another one is that in the new health facilities, it could be used to put in place the right caliber of health personnel to operate them so as to meet the requirements of the World Health Organization. And another one is that to make the best use of most reliable resources in accordance with the organizational goals. Method of assigning manpower in health facilities. And this is simply the process of systematically looking at manpower needs to ensure that the required number of employees with the appropriate skills are available when they are needed. That was what I explained in the previous slides. And when you are doing this, you can base it on the health needs. That is the first one. You can as well base it on service targets. That is the required target that you want your manpower, that is your health personnel, to do for you. It can as well be based on health demand, depending on what you have and what is in vogue as of the moment that you want to do your planning. Then health manpower supply has to do with forecasting the future health manpower supply, or the availability in right quantity and in right quality at the right time. So most times it is equal to staff in post minus the leavers plus the joiners, putting it in a nutshell. So if you want to say it briefly or concisely, it could be said that health manpower supply is more or less the staff in post and minus those leavers plus the joiners. Now, a number of techniques have been used by health planners to forecast the need for, demand for, and supply of health manpower at specific time and at specific places. There are some basic models for estimating these requirements, and this include the professionally defined criteria which are known. Another one is that the current utilization rate of comprehensive prepaid group plans, and also medical personnel to population ratios, and that of the economic systematics. Now, developmental health and goals of health plan. Now, according to Keating in 1999, he actually defined developmental health as the physical and mental well-being, coping and competence of human being. And by extension, it is the combination of health and developmental outcomes. Now, there are some goals of health plan, and this includes the tools and resources to help manage health system. Excuse me. Now, sorry, I quickly attend to something. Now, so there are some health plan goals that we need to put, and we need to give paramount importance whenever we are planning our, our health facilities, or even where we are as of now, especially some of us that belongs to the management level or cadre, so to say. Now, one of it is the tools and resources to help you manage your health facilities and finances must be given a very good importance whenever you are trying to have your health plan. Also, ongoing support, including disease-specific treatment programs, access to one of the largest networks of doctors and hospitals in the country. And in fact, I want to say that even beyond, might not really be in the country of residence alone, and even beyond. Another one is that great customer service from a dedicated team of professionals. Okay, now let's talk about health policy. Health policy, as we all know, is the decisions, plans, and actions that are taken to achieve specific healthcare goals within a society. And for this, there are many categories, so to say, of health policies. And here I've mentioned three of them, which include the personal healthcare policy, the pharmaceutical policy, the policies related to public health, such as vaccination policy, tobacco control policy, breastfeeding policy, and a number of others like that. Now let's move to immunization and the types of immunization. Immunization protects people from disease, and by introducing a vaccine into the body that triggers an antibody response as if one had been exposed to disease naturally. Now, for the purpose of this, we know we have types of immunization which can indeed be passive or active immunization. Now, when we talk about active immunization, this means that they occur naturally whenever anybody or the person in question comes in contact with microbe. But by way of passive immunization, it is much natural. Such has to be pre-sensitized with elements of immunology, so to say. That is, some pre-sensitized element has to initially be induced into the body system of the person, so that when the body comes in contact with such microbe, it will be able to produce the needed immunity against such a disease or microbe. Management functions. The management functions are most easily described as logical sequences of activities, although in practice they are carried out in whatever order that is appropriate. So it means the management functions, we may not say that we have specific model with which it should be carried out. So it depends on individual's health facility or individual health organization. So that's what we inform as to how to go about, you implementing the function. And some of these functions are planning, we have organizing, we have directing, we have coordinating, we have staffing, we have controlling, and a number of them like that. I think you can read those ones up there in your study guide because of our time, because we still have like 1 or 2 slides that I want us to go through. Now, characteristics of planning organization. Now, some of the characteristics of planning organization is that it increases the efficiency of such organization, and the risk involved in modern business activities are being averted when when organization is being planned adequately, and it also aids time and resources management. The concept of planning is to identify what the organization wants to do by using the 4 questions, which are: where are we today in terms of our business or strategy planning? Where are we going next? Where do we want to go? How do we get to where we want to go? So those are the 4 questions that our planning should be answering if our planning is to be effective. Now, let's talk about the importance of health data. Now, health data are important because they measure a wide range of health indicators in our society. And for this purpose, we have some sources of routine data to describe the distribution of health challenges. It might not really be diseases. We have some of them like that in order to describe the distribution of health challenges in our society, and part of it are the demographic data from census and population registers, from death certificates, from cancer registrations, from birth registrations, which is the natality. That of death can also be the mortality. That B could be mortality, and G can be the natality. Then from congenital malformations registrations, infectious diseases notifications, hospital episode data, health survey, and a number of other surveys like that. I think with this, we technically come to the end, but I want you to, I want to give room for one or two uh, questions before we call it a day. Page 201. Dobi.
Hi, sir. Good afternoon.
Good afternoon.
Okay. I'd like to ask. First of all, I don't know if you can take it back to the first outline of your the courses you read. I just want to view the outline from session 1 to the last session.
You mean this one?
No, the next one.
The next one?
No, this one.
Okay.
Yes. And then secondly, I don't know, because it seems, I know it's actually in a rush, everybody's rushing to get the finish up, but do we need to bother ourselves about reading the other places you did touch, or we should just concentrate on what you've just taught us?
Is that a question?
Yes.
All right. Next person. Page 201. We are not hearing you clearly. Unmute yourself. I'm not hearing you. Okuku Sarah. Okuku.
Good afternoon, sir.
Good afternoon.
Hello.
We are hearing you. We are hearing you.
Good afternoon, sir.
Good afternoon.
My question is standard deviation.
All right.
The formula for standard deviation.
Okay.
And for the sake of this exam, I will calculator.
Can't you solve? Can't you solve standard deviation without using a calculator? Are you scared?
At least it's a timed exam, and we want to meet up with the exam with the time. So if you're permitted to use a calculator, I see it's going to be an online exam. So
anyway, we will decide on that later.
it's okay, sir.
Okay, ni onome or something.
Good afternoon, sir.
Good afternoon.
Thank you for the lecture. So my question is under rules of probability. I didn't really get the explanation.
Okay. Beauty Oyechi. Beauty Oyechi. Oyechi.
Okay, good afternoon, sir.
Good afternoon.
Can you hear me, sir?
I'm with you. I'm with you.
Okay, my question is on probability.
All right.
The area we are explaining about the set,
Okay.
the intersection and all that, I didn't really get that side.
Okay.
Thank you, sir.
Elizabeth.
This question. Good day, sir.
Thank you.
Hello, good day, sir.
Go ahead. Go ahead.
Hello?
Go ahead. I'm hearing you.
All right, thank you, sir, for the lecture. Please, can the slide be replayed, please? Because some of us didn't get the explanation along with you, please.
Okay.
Thank you, sir.
Miriam.
Hello, good evening, sir.
Good afternoon.
Thank you for the lecture, sir. My question is already answerable. Is to the law of probability.
Okay. All right. Obande Jessica Alaba.
Hello, good day, sir.
Good day.
Good afternoon.
Good afternoon. We are not hearing you clearly. Good afternoon. We are hearing you now.
Yes, sir. Please, mine is not a question. No, I just want to ask if we can get the slides so that we can go through, because some of us did not start with you on time.
Okay.
Hello?
It's okay. Who again? Infinix. Phoenix X5. Infinix X5. You are just talking. You raise.
Àwọn èèyàn máa béèrè pé eléyìí ò fà á tí kò ó mú fún dókítà kan ní ó wá ń ṣe kínní 4,000 tí ẹ mo fẹ́ tà fún dáná ó wá ń ṣe.
PSG 201. PSG 201. PSG 201. Great Agbomi. Great Agbomi.
Okay, good afternoon, sir.
Okay, good afternoon.
Okay, thank you so much for the lecture. But my question basically is on probability.
Okay.
The probability aspect of the lecture, I did not get it. Although on my own, I've been trying to understand, especially when it comes to the question, the part of when you throw a dice and all of that, I cannot seem to follow.
All right. I think that's all. There is no other person again. PhD 201. Who is this PhD 201? You said? I can't hear you. Okay, let me take you to seems majority of the questions are from on probability. Okay. Now, this is just, if you are seeing this slide, this is just an explanation. I don't know how to put it. This is just a kind of event. Yes, this is just a kind of events that naturally may happen. And the first one is that you can have joint probabilities. You can have interdependent events. That is, you can have joint events, interdependent events, mutually exclusive events, not mutually exclusive events. Then we have conditional events, which is also conditional probability. Now, you may not really bother yourself much about this, but what I'm just trying to, the reason for just trying to make this one, the reason I'm just trying to explain this one is just for you to have a kind of overview of what we have done here. But now, if you look at this joint probability now of A and B, now take for instance you have event A and you have event B. Now, there is now a kind of the two events became interwoven. That is, at some point they entered into though not completely. Now, that's when we are talking about intersection. And mathematically, once you have A and B, it means this and in probability means intersection. Are you with me? Once you see event X and Y, it means X intersection Y. If you see events A and C, it means A intersection C, and so on and so forth. Now, if you now have interdependent events, like you have here now, they say probability of A and B. Don't forget we said and is the same thing as intersection. So that's how we have this one now. A intersection B, A and B, A intersection B. They now say that by this principle of multiplication, I make mention of some laws here. Please remember of some laws here. It means that you can split, just like you expand this bracket now. Are you with me? It's just like you have X, or let me say you have 2 into bracket X plus Y, and you now expand it. You have 2 times X, then times 2 times Y, kind of, although not really like that. Now, what we have there is you open this, you expand this bracket, that if it is in this form too, you still have what you have here. You understand me? So we have probability of A is the same thing as probability of A times probability of B. That is what we mean by interdependent event. Now, but if it is now mutually exclusive event, now it means you have A or B. That is, the two cannot happen at the same time. Are you with me? The two cannot have the same value. That is, A, therefore, you are talking about an event that will happen, that somebody want to marry and somebody wants to put to bed. Now, under normal circumstance, if not for somebody that had conceived before she got married or he got married, now it's hardly will you see somebody that will get married today and the person will give birth that day, except the person had married, had conceived earlier. So that's what we are trying to say here, that when an event or when 2 events are mutually exclusive, it means that one will occur, the other will not occur. So, and that you can see again is either A or B. That's the meaning of mutually exclusive, A or B. So when you have that, mathematically now, it is now union. It means A union B. Don't forget that when we say and mathematically and means intersection B and means intersection or means union. So when you now break that, then you have consequentially you have plus, you have A and you have probability of A plus probability of B. Unlike that of interdependence, which is probability of A times probability of P or B. Now, they now said if it is not mutually exclusive, which means the two can happen. You get it? When it's mutually exclusive, one will happen. But if it is not mutually exclusive, it means the two can happen. So it means A plus B minus A and B. So you have to subtract this. Just like what I explained, that if you throw a coin up, we all know that it will be either head or tail. Now, if it is head or tail, now if you throw it up, once it comes down, you are going to see head or tail. So it's either head or tail. So and the probability of the two happening is 2. So if head happen, it is 1/2. If tail happen, it is 1/2. But if they now tell you that what is the probability that head will not happen, you now have 1 minus half. That is 1 minus probability that thing will happen. So it is the same thing that we have done here, that you now subtract the probability that it will happen from probability that it will not happen. Probability mutually exclusive means this thing, one will happen. That's what you have put here. Probability of A plus probability of B. Then minus probability that the two will happen. So that's what you are doing. Now, you can leave this conditional. This one is a little bit below your level now, but I just put it there maybe to give you an insight. But when you get to higher levels, you get it better. Now, let me now use these 3 principles to explain this diagram to you. Now, what we are now saying is that it is what we have here. It is these things that we have here. This mathematical, or let me say, probability relationship that we have represented in this diagram. We have 2 events, A, B, and C is the environment or the sample space that the sample space is S that these 3 events are happening. You have A, you have B, and you have C. But what you are saying is that at this point, this red area, there is intersection. That is, the action of A got into action of B. So the 2 here, what we have here is what? Is A intersection B at this center. Now, what is not saying is that if you want to get C, it means that you will get, okay, let me show you, let me say this. It means A plus B minus A minus S. Let me say it like that. Now, S means the all of these things now. But you want to know what C will be. So, you know, it has been said here that C is, let me zoom in so that you see clearly. Okay. Know that A plus B is the probability of A and B. And that A plus B means what? It means A union B. Do you understand? If you match the 2 together, union means you marry them together. Intersection means where they connect. So point of connection between event A and event B is intersection. If you match them together, that means you marry them together. That is the 2 of them coming together, you mix them together, rice and beans, dance. I think you are getting the analogy. Now, what you are now trying to say is that C now, the value for this C now, you are trying to subtract. C means this, this complement. Complement means minus. So if you say A union B minus this complement that you are seeing, you can see my cursor here, it means minus. So now, when you now say it like that, now when you go back here, A union B is probability of A plus probability of B. That's what we have here. We are trying to expand this A union B in this next expression. So A plus B, like what you have there. You see A plus B. Where is it? A plus B. That which is the second, the third one. A plus B means A union B. So that's what we have here. Then you now subtract this one, this intersection, you subtract it from it. That's minus A. So this one now is what is referred to as this thing that you are seeing is complement. This minus A intersection B means this complement that you are seeing in this C. This one now, you can see that it's A union B complement. It means A plus B minus A intersection B. That is A, you are trying to add this all this yellow part plus this blue part minus this red part. That's what you are doing here. So if you are being given in form of question, take for instance, they tell you that the people that came for HIV test are here, and those that came for what other test is common in the hospital? Maybe the people that came for what other test? You can remind me. So now, the people for HIV test and the people for sexually transmitted disease, of course, that one too is HIV, but let's assume it like that to have better understanding. So they now say that how many of them, maybe during at a point in time, some of those people that came for HIV test too, they also come for this other test too. Are you getting it? So that is what I'm trying to explain here, that A intersection B, that is the people that came for test A and also observe test B, they are these people. So if you want to get this A and B alone, then you have to subtract these people. Are you getting it? So that's just simply what I just explained. I don't know whether you get it clear, but you may not really need to bother yourself, especially about this third one. I mean this one, this conditional probability, and even this one, I may not categorically tell, but I think I'll be able to do justice to that. So what we are trying to say here is that we want to get the whole people. Let's say C is the total number of patients that come to health facility in a day. Now, the total people now, the people that came for gynecological tests, those for other tests, just name them. Those that just come for medical checkup, everybody is C now. Now, part of those C now, some are for malaria, some are for, let's say B is for malaria, then B is for maybe typhoid. Let me use like that. So A is for malaria, B the people that come for typhoid test or something. Now, but don't forget that those A and B, they are also included in C, because C is your total people, is the total patient that came to your health facility. Now, what we are now saying is that if you want to know, you know that A and B too is included in C, but you want to know the sole people that come for malaria and typhoid fever alone. So if you now want to get that, that is the expression for you need to get it that we have explained here. So if you want to get C, that is the people who did not come for, the people that did not come for malaria test and they did not come for typhoid, C, it means A union B complement. So that complement is what we have is A intersection B. Any other question? I think we have spent so much time. Any other question? I don't know whether I've been able to do that before we start going. Okuku Sarah.
Hello, sir.
Hello.
My question has not been answered. Formula for standard deviation, sir.
Okay. But even hello, Okuku. The formula is in your material. So you can have it in your material, it's there. So just get your frequency distribution table. You get approach to frequency distribution table. You get your assumed mean. Then you subtract it all over n, which is the total number of the observation. Then you have another table. You take the square root. That is your standard deviation. Alaba. Oladejo Aishat. Oladejo. PhD 201. Oladejo. Okay, you are just raising your hand, you are not speaking up. Anyway, with this, we have come to the end of this technology-driven facilitation. And I hope at one point or the other, you have really gotten one understanding of the other. So regarding the subject matter, which is PhD 201, Biostatistics. So on this note, I want to implore you all to go over your study guide, especially the specific places I've mentioned in these slides, and in this facilitation. And I want to say that don't forget that this slide actually covered all the 9 study sessions that you have in biostatistics. So, which means you have really been opportune to have the necessary knowledge of biostatistics within a short while. So on this note, I want to wish you the best of luck in your forthcoming semester's examination. Thank you for your rapt attention. Thank you.